Hello everyone, I'm Gongyu Tang and this is my project report. My topic is optimization of bin packing problem. There are 4 parts in my project report. First is introduction to my problem. My topic is bin packing problem. Consider I have I packages. I need to put all of the packages into bin G, and my aim is to find the least number of G to contain all of the I packages. I made a simplify of the problem. Consider we have 20 packages and a bin with infinite height and constant width with W equal to 20. I need to put all of the packages into this bin, and my aim turn to find the H, which is the maximum height when I put in all of the packages. And my objective function is to find the minimum of H. My constraints are for each y, the sum of packages length must be less than 20, and all of the packages are settled in the same way, length in the x direction, y in the y direction, and the package must be settled with zero gap to the package in its left side. Here is the algorithm I used. I used a heuristic recursive algorithm to find the solution, and this is a plot to show this algorithm. I need to use a recursive algorithm to recursive the space S2, S3, and S4, and this is my recursive algorithm. And the order when I set in the package is depend on the area of the package, from the largest one to the smallest one. And I use this heuristic recursive algorithm to find the solution, but this is not the best solution, and it doesn't consider the rotation. So I use the genetic algorithm to make a better result. And there are 6 parts in my genetic algorithm. First, a code. I generate a matrix 20 by 2 to represent the order when I set in the box and the rotation. And my basic generation is I use a random decimal to generate a basic order and rotation. My fitting function is to use a heuristic recursive algorithm to calculate the H. And for the mating, I make 2 chromosome group, generate a random decimal if this number is less than PC, which means the mating probability mating 2 chromosomes, otherwise not mate. And the mutation, I generate a random decimal for each chromosome if this number is less than PM. Then I random generate a new decimal to replace a former decimal in the chromosome. And here's my parameter for the genetic algorithm. Population is 200, generation is 500, and PC equals to 0.8, PM equals to 0.05. Here's my result. I use a heuristic recursive algorithm to get a result. And this plot is how I set in all of the packages. And the H is equal to 38. And this is the plot when I use GA and the heuristic recursive algorithm. And H is equal to 33, and which means GA found a better solution. And this is my project report. Thank you for all of you listening to my project report.